Okay, good morning. So, we will start our class now. So, this is our last topic on abstract algebra. Yes, Al-Nasir, may tanong po ba?
Wala ma'am, napindot ko lang ma'am.
Okay. So, we will be discussing on cosets and normal subgroups. So, actually, no, last week, I already uploaded the problem set and the final exam natin na worth of, I don't know kung 50 ba yun. Basta mayroong tayong, nakalagay na dun sa Google Classroom natin last week pa, yung problem set and the final exam. So, ang due date nun will be on the second week of June ata. So, tingnan nyo na lang dun, no? Kasi nandun naman yung deadline nun. So, after ng klase natin today, we will not meet anymore. So, ito na po yung ating last Google Meet app. So, yung ibang time natin, kasi ang schedule kasi ng ating final exam will be on the second week of June, June 9, 10, 11. So, yung gagawin ninyo na final ay nai-post ko na. So, sasubmit nyo na lang. Okay? And then, after the final week, so give me time to compute and do the grades mga 2 weeks after the final week schedule. Okay, so yung final exam natin no, parehas lang din sa problem set natin. Kaso lang yung problem set it comprises the coverage is from the first day of our lecture. While the final exam, the coverage is only on the module 3, which is the permutation, cyclic groups, and this one, the cosets and the normal subgroups. Okay? So, i-discuss ko ngayon yung cosets and normal subgroups. 10 slides lang to, hoping it will, maaga-aga tayo dito, and hoping we understand this all, no? Lahat tayo yung makakaintindi dito sa cosets and normal subgroups. Okay. So, what is cosets or counting cosets? Kasi bakit siya tinawag counting cosets? Kasi meron siya, ang cosets kasi may left and right cosets at kinakount niya kung ilang cosets meron. Kaya nga tinawag siyang counting cosets. So, we let G be a group and H is a subgroup of G. Or pwede ding we let H to be a subgroup of a group G. Ganyan. So, for any element A in G, so any elements ang A na sa G, G wherein G is the group. So, the symbol, itong symbol, it pertains to the left coset of H, which is in G. The left coset of H, ang H is yung subgroup, okay? AH is the left coset of H in G. So this denotes the set of all products AH as A remains fixed and H ranges over H. Yan po yung AH. A remain fixed po si A, and H ranges over H. Or pwede natin ganitong basahin. AH such that H is the element of H of G. Kasi H is a subgroup of G, di ba? We let this one here. So, yan. So, AH is the left coset of H in G. And in similar fashion, meron din tayong HA. So, HA is the right coset of H in G. Or ito lang din. It is an element of HA such that H is element of H of G. So, yung HH na yan is the set of all products HA wherein A remains fixed and H ranges over the H, capital H, which is a subgroup of a group G. Okay? So, yan po yung counting coset. So, kakount natin yung left coset and the right coset. So, meron tayong AH, which is the left cosets, and HA, which is the right cosets. So, kung saan yung A, yun po yung magiging basehan natin. Pag nasa left siya ng H, so that is a left coset of H in G. Pag nasa right siya, that is the right coset of H in G. Okay, so we have here a note. So every coset in G is a subset of G. So, yun na yun, no? Yung nakita natin na ang coset ni H, so, yung mga element doon is a subset of G. So, every coset in G is a subset of G. When we say coset, we mean right coset. Pero pag sinabi natin get or find the left coset and the right coset, so may binigay siyang kung ano yung kukunin natin. Pero pag coset lang, it automatically mean right coset. Okay? So, improving two cosets, yan. So, improving two cosets, itong HA and in HB na equal daw. So, for example, no, si HA and HB. So, they are all on the right cosets where A is fixed, ranges to H, and here is B is fixed, ranges to B. Ranges over H din. So, we must show that they are equal sets. So, para makita natin na itong cosets dito ay magkaparehas yan, dapat magkaparehas na yung kanilang set. Anong ibig sabihin nun? Every element X, which is an element of HA, is in HB. Dapat na yung mga elements sa HA nasa HB. Tapos, yung every element sa Y, element of HB, element daw nito ay nasa HA din. So, dapat ganun yun. They are all equal sets. So, all of the elements in HA must be in HB. All of elements in HB must be in HA. So that we can tell that these two cosets are equal. Yun po yung important note dyan. Okay. So, we have here an example, no? Example of this one is that we will prove that these two cosets, HA and HB, are equal. So, we will prove that one. Okay. So, we have here, if A is an element of HB, then HA is equal to HB. So, ano nangyari? So, this means that yan yung given muna. Galing yan dito sa if. Sinabi man, if A is element of HB. So, pag ang A is an element of HB, it means that meron siyang ganito. Yan. Meron siya, yung A is equals to H1B for some H1 element of H. So, yung H, yung capital H na yan, kasi is a subgroup man, no? So, it has many elements. So, we assume meron siyang element na H1, which is, change lang natin dito, di ba? Naging ganyan mo yun siya, oh. Pag ganyan, no? So, pag gusto mong gagawin na meron lang siyang equal sign, so, ililiit lang po natin si H. Gagawin natin H1, wherein H1 is an element of H. Yon. Okay? Ngayon, this is, kasi dito yan siya, no? We let na if A is element of H, so this means ganun siya. Tapos, ipoprove natin na si HA ay equivalent to HB. Yon. Erase muna natin. Okay, so we have the first part. So, let X is an element of HA. So, i-let natin, no? Merong element si HA na certain variable which is X. So, pag meron siyang element sa HA, yan, di ba? Element siya. So, we can say, meron siyang H2A. Yan. Bakit ko ginamit ang H2A? Kasi in-specify ko naman si H1 dito. Or pwede din naman H1A. Basta be sure, ma-clarify natin yan later on. Kasi we let na here, dito sa taas, kasi if A is equals to HB, so yung HA, kasi HB siya, no? HB. So, A is an element of HB. So, and we specify na H1 dito. So, sa HA, gagamitin na natin si H2. Kasi si B ay ginamit na niya yung H1. Okay? Kasi para hindi siya ma-overlap yung H1, H2 element. Okay? So, yun na. Next. Erase muna natin to. So, we already let this one and let also this one. Kaya kasi gagamitin natin yan. Tingnan nyo. But but A is equals to H1B since we let na A is an element of HB. Okay. So now, gagawin natin to. So, X is equals to H2A. So since we already we'll already assume here na si A is equals to H1B, we will substitute lang yung A. So, X equals to H2 times H1B. Since we're dealing with groups and subgroups, no, which is the H, so therefore, this is associative. Yan. Associative siya. So, pwede siyang i-regroup. For this one, sinabi natin dito, sana yun? Bakit nawala siya? Kasi dapat meron pa to dito, ha? For some H2, wait lang, ha? So, dapat meron pa tong ganito. For some H2, H1, element of H. Yan. Bakit yan ganyan? Diba we all know, if H1 is an element of H, and H2 is an element of H, therefore, their product is an element of H also because this is a subgroup. The closure property exists, di ba? Recap tayo. In a subgroup, closure property exists. It can be a product or a sum, di ba? Pwede siyang addition or multiplication, yung binary operations, okay? So this is true. Hence, clearly, X is an element of HA which is in HB. Bakit niya sinabi yan? Tingnan natin. Since H2 and H1 closure property is an element of H, Therefore, nakikita natin na si X element which is in HA is also equivalent na yung X element na sa HB din siya. So, therefore, kinabi niya, X which is an element of HA is also in HB. So, nakita na natin yon. So, pwede na yung sasabihin na if A is element of HB, then HA is equals to HB. Or, pwede din ito, kasi ito is another proving, pwede din ito, sasabihin natin. For example, ang given nyo is HB. So, titingnan natin kung parehas din siya sa HA. Kasi dito, ang given natin is HA, tapos given na naman ito, tapos kinompute kung parehas sila. Wait. Next, so we assume there is a certain y variable element in HB. So this means that y is yH1b for some H1 element of H. So sinabi niya dito, no, but B is in H2A. Saan yan si B? Okay, wala siyang in-explain kung saan niya kinuha si B. Okay, titingnan natin, no? Wait lang. So, don't forget itong for sum, ah. So, dito na tayo sa number 2. So, in-explain niya, there is a certain variable y, element of HB. So, therefore, y is equals to H1b. So, ngayon, in-assume niya dito, dapat hindi siya gagamit ng but. Okay? So, we assume, okay. So, dapat, since, lagay natin since ha, since B is an element of HB, so assuming B na lang, kasi dito ginamit natin si A. So, since B is an element of HB, tingnan nyo, may mali eh. HA. HA yan, kasi we assume na HB dito. Okay. Wait, eraser. Kasi ganyan na, take note. Pag in-assume na natin HB, yung isa is HA kasi we're talking about HA and HB. So pag in-assume muna natin yung HA, then yung isa is HB. For this number 2, in-assume natin si B. So yung isa is element siya ni HA. Yon. Paki-erase, paki-correct lang to, HA. Yan, HA. Hindi na pasok. Hindi siya masulat sa dulo. Okay, since B is an element of HA, so since H1 na to, no? So B now must be equals to H2A. So ngayon, substitute lang natin si B. Therefore, or now, Y is equals to H1B. So Y equals to H1, H2A. Then we're in groups. Then we're talking about subgroups there. Therefore, associativity exists. So yan, associativity. Nag-iba yung kanyang grouping. Tapos sabihin lang natin dito, no, kailangan for some H1, H2, element of H. Yan. Manalamiton pang for some. Kasi kailangan i-specify natin. Kasi from the previous, wala tayong specify na si H1, H2 is element of H. Kundi i-specify lang natin na si H1 is element of H, H2 is element of H, but walang H1, H2. Specify ninyo yan. Since closure property exists naman in the groups and subgroups. Okay, so since we specify H1, H2 is in there, therefore we can say that clearly Y is an element of HB from our first part is in HA also on the second part. Yan no, A yan dyan. I-edit ko lang yung mamaya sa lecture nyo. So tapos, naipakita na natin na all of the elements in HA is in HB, or yung all of the element in HB is also ni HA. So therefore, we can say, yan. Therefore, HA is equivalent to HB. So ganun lang po yung ipakita natin. Using the cosets, definitions, the left and the right coset, we can, dito no, ginamit niya is right cosets lang kasi pwede naman yung right cosets lang ipakita. So using the right cosets, we can determine whether the two cosets are the same. Ito na, si HA and HB. Okay, so that is how you prove whether the two elements or the two cosets are the same by stating that all of their elements in HA is in HB and all of the elements in HB is in SA. Yon. Okay, so now we're finished discussing the definitions of a coset. Time check natin. Time check is already 8, so I have 1 hour. Okay, so sa theorems na tayo, no? Sa theorem 1, we have the family of all cosets HA. So HA na, take note, HA is the right coset. As A range over G is a partition of G. Ayan, yan yung drawing. Ito yung HA. So the family of all cosets HA. As A ranges over G is a partition of G. So yung partition, yung parang dinivide. Yan. So we assume merong HE, SC, HB. So apat na partition. So ano ipoproof natin? We must show that any two cosets, so any two, kahit sino, no? So nag-select na lang ng say HA and HB. Ay either disjoint or equal. So ibig sabihin, ang disjoint ay magka-separate. Di ba? Sinabi ko naman sa disjoint doon sa ating permutations kung ano yon. Nag-stop yung kanilang cycle or permutations. Yun po yung disjoint. Ngayon, yung equal, ibig sabihin, all of their elements are in HA, say HA and HB man, no? So, all of the elements of HA is in HB. So, yung elements ni HB, nasa HA din. So, ngayon, kung disjoint, ibig sabihin, yung elements ni HA ay wala kay HB. Yung elements ni HB ay wala kay HA. Yun yung po yung disjoint. Kasi nandun naman, discuss ko naman yung disjoint cycle, di ba? May disjoint cycle, ibig sabihin, hindi na continuous. Tapos makikita nyo, magkaiba yung kanilang number or elements. Okay. So, case 1. If HA and HB are disjoints, then we are done. Obviously, pag sasabihin natin disjoint, wala silang the same element. So, there's no proving na kailangan gawin dyan. Kasi, we assume na wala silang parehas na element. They are disjoint. So, we are done. So, ngayon, papakita natin how about if they are equal? So, pag they are equal, yun na yung ginawa nating last kanina. Sana yun? Ito. Kasi dito, pinakita natin na yung dalawang cosets ay magkaparehas. So, ito na yung ginawa natin sa case 2. Yan. ito ay parehas. So, hindi ko na-explain kasi, di ba? Sinabi ko naman dito. In-explain ko na. Okay, so since we show that every element C is an element of G is in one cosets of H, so, yan. Pinakita niya lang na merong identity element. Bakit kailangan pa ipakita yung identity element? It's because if the identity exists and so the tawag dyan, if the identity exists and so there is an existence of inverse. So since na-exist po si identity, therefore itong si H is also a subgroup. And all of the family of all of the cosets of H, kasi we assume no HA, so dito yung HB, so lahat yan ay H. So that is a subgroup. Therefore, this H is a partition of G. So yun po yung theorem 1, wherein the family of all cosets HA as A range over G is a partition of G. So minsan hindi pa natin ma-determine talaga o ma-gets kung anong ibig sabihin ng theorem 1. So this theorem can only add meaning when we're dealing with proving. So for the meantime, in these cosets, lahat po tayo ay parang wala pong mostly proving. Ito ay isa lang getting the cosets, the left and the right cosets of a certain ano yung tawag dyan? Groups. Okay? So we have also theorem 2. Yan. If HA is any coset of H. So kahit any cosets, ibig sabihin we assume lang no si HA is any coset of H. Can be HB, HC. So assume lang natin merong isa. So HA is any coset of H. Therefore, there is a 1-to-1 correspondence from H to HA. Ano yung ibig sabihin ng 1-to-1? 'Di ba? From H going to isa. So 1-to-1 yung kanyang element. Yun po yung ibig sabihin ng 1-to-1 correspondence. Okay, so ganun po sa theorem 2. Ang theorem 3, which is the Lagrange theorem, ang Lagrange theorem, anong ibig sabihin ng Lagrange? Ito yung kanyang theorem. Let G be a finite group and H any subgroup of G. The order of G is a multiple of the order of H. Anong ibig sabihin nun? Yung order ng G is a multiple of the order of H. So, for example, so this means, later na example, no? So, in other words, the order of any subgroup of a group G is a divisor or a multiple of the order of G. For example, si G ay may 15 elements. So, ang kanyang proper subgroups may have either 3 elements or 5 elements. Saan tong kinuha ang 3 and 5? Di ba sinabi it's a multiple or a divisor? So, for example, no, ang 15, ano ang factor ng 15? It's 3 and 5. Kaya yun po yung Lagrange theorem. So, the proper subgroup may have either 3 elements or 5 elements. For example, we have 10. G has 10 elements. So, therefore, ang kanyang factor is 2 and 5. So, the proper subgroup of that group G may have either 2 elements or 5 elements. So, yun po yung Lagrange theorem. Getting the divisor, we can automatically getting the divisor, we can automatically using the Lagrange theorem, we can automatically determine the subgroup kung ilang elements meron. Yun po yung purpose ni theorem 3, which is or also known as Lagrange theorem. The multiple, factor or the divisor of that um, group. Okay, for example, si G, no, 15 elements, so 3 and 5. If G has 10 elements, 2 and 5. If G has 14, 2 and 7. So, ganun po. Getting the multiple or the factor or a divisor. Okay? So, next, theorem 4. Ang theorem 4 naman, if G is a group with a prime number P of elements, then G is a cyclic group. So we all know what is a prime number, no? Prime number, yung mga numbers that can only be divided by 1 and itself. So yun po yung prime number, okay? So cyclic, we already discussed this. What is a cyclic group? Okay. So furthermore, any elements A which is not equivalent to E in G is a generator of G. So for example, don't worry, no, we will appreciate this cosets and their theorem through an example. Hindi pa itong example. May ibang example pa kung ibibigay after ng lahat ng theorem. Okay? So for example, for the theorem 4, so the only group of order 7 is Z7. And the only group of order 11 is Z11. Bakit yan? It's because 7 is a prime number and 11 is a prime number. So therefore, automatic, ang group na ito, which is C7, ang order niya is 7. Itong 11, ang order niya is 11. Take note ha, this is only true for the prime number of elements. Pag ang element niya is a prime number, automatic yung order niya, the only order will be 7, no more. Hindi siya ang Z7 hindi siya pwedeng maging order 1, order 2, order 3, order 4, order 5. Only order 7. And this is only true for a prime number elements. Okay? Take note of that. Prime number lang po ang pwedeng sabihin dito. Suitable for this one. Only a prime number of elements. Okay? And the last one, theorem 5, which is also known as the index of a subgroup. So ano tong index? The order of any element of a finite group divides the order of the group. Yun po. The order of any elements of a finite group divides the order of a group. So ito yung nangyayari dito. Yan. So if ever H is in group G, so the index of H in G is the number of cosets of H in G. So pag i-divide natin, yan po yung number ng cosets meron si H in G. So paano natin gagamitin yan? So later on sa example yan, no, makikita natin. So ito, basahin nyo na lang yan. Pwede naman, may time pa pala ako. Okay. So let H be a subgroup of G. The number of distinct left coset of H in G is called the index of H in G. So ito yung ating formula. So in getting the index of G, get the order of G, yan, divided by the order of H. G is the group and H is the subgroup. So ano yung order ng group, i-divide mo sa order ng H. So later on, makikita natin yan through an example. Okay, so meron tayong remarks dito. Even if the left cosets and the right cosets are not equal for non-abelian groups. Non-abelian groups, they do not commute. Okay? Abelian kasi commutative groups to. So ito ay mga groups na hindi nagko-commute, tapos yung left and right cosets niya are not equal. But kahit hindi parehas, there will still be the same number of distinct right cosets as left cosets. Ibig sabihin, yung ilang right cosets meron, yun din yung left cosets. Kahit magkaiba yung kanilang elements. Yun po yung ibig sabihin dyan. Next, every cosets, it's either left or right of a subgroup of H of a group G has the same number of elements as H. So, magkaparehas po yung cosets, right or left, ang kanilang number of elements sa H. So, for example, yung number elements ng H is 2 elements. So, yung left and right, 2 elements din yan meron. Okay? Take note of that. So, we will have this so that we can appreciate kung ano yung sinasabi ko sa mga theorems and definitions through an example. So, dito tayo sa example. So, first one, find the left and right cosets of 3Z as a subgroup of Z. So, we all know what are Z. They are the integers, the whole number. Ng integers kasama si 0. So, whole number lang po, no? Negative whole numbers, 0, and the positive whole numbers. So, we're talking about that group G. Pero yung subgroup niya, all of a multiples of 3. So, lahat lang ng multiples ng 3, which is a subgroup of the group Z. Okay. So, we all know, 3Z is a set of integers that contains elements of Z which are multiples of 3. Ngayon, we will found the left cosets. So, ang left cosets looks like this one. Yan. So, we assume there is a letter M. So, letter M. So, we will try to see the 0, 1, 2. So, we assume mag-a-add tayo ng 0 sa 3Z, 1 sa 3Z, and 2 sa 3Z. Pag 0, 3Z lang or 3Z, ito yung kanyang elements. If we add 1, so add 1 to negative 9, negative 8, add 1 to negative 6, negative 5, add 1 to negative 3, negative 2, and so on. Then we add 2. So negative 7, negative 4, negative 1, 2, 5, 8, 11, and so on. Yan. Yan po yung mga elements. Ganyan po yung kukunin ninyo. But this time, this is only the left coset. LC stands for left cosets. So this is for left cosets only. Kasi yung right coset, magiging ganyan na siya. 3Z plus M. Yan po yung right coset. It can be 3Z plus 0. So we already start with 0, no? 3Z plus 1 and 3Z plus 2. Yan. So these three left cosets constitutes the partition of Z into the left cosets of 3Z. Since addition is commutative, RC of 3Z is equivalent to LZ of 3Z. Yes, di ba? Gagawin natin tong 3Z plus 0. Parehas lang namin sa 0 plus 3Z. 3Z plus 1, parehas na namin yung answer sa 1 plus 3Z. 3Z plus 2 ay parehas lang din sa 2 plus 3Z. Kasi si addition is commutative, so pwede na natin sabihin si RC of or right cosets of 3C is equivalent to the left coset of 3C. Okay? So yun po. Yun lang, sasabihin nyo lang, RC of 3C is equivalent to LC of 3C. So we have a note here. For subgroup H of an abelian group G, the partition G into left cosets of H and the partition into the right cosets are the same. Take note niyo yun, ha? Basta abelian group. Ibig sabihin, naga-commute. Kasi we found out this one here, kasi si addition is commutative, and hence is abelian group. So yung right cosets niya and left cosets are the same. So kaya ilagay ko na dito ng note. For subgroup H of an abelian group G, the partition into the left cosets and the right cosets are the same. Okay, so this is an example of how we get the left and the right cosets. So we have another example. The group C6, Isang abelian. So, pag abelian, anong ibig sabihin natin doon kanina? Pag abelian, yung left and the right cosets are the same. Pag the same, so kukunin lang natin yung cosets, hindi na natin sabihin na left and right. Pwede din sabihin, pwede naman left cosets kunin, and then sasabihin natin, the left and the right cosets are the same since they are abelian. So this time, kinuha ko lang yung left cosets, and then sinabi ko na yan na po ang lahat ng cosets. Okay? So ngayon, anong sinabi dito? Find the partition. So sa partition ng sinabi. So wala siyang sinabi na kukunin mo si left and the right. Kasi we assume na this C6 is abelian group. So wala na siyang sinabing left and right cosets. So kung saan kayong komportable, yun na lang. And then give the partition. So yung subgroup is ito. Yan po yung subgroup. So, ano-ano yung mga cosets? So, we can know that these are the coset if it satisfies or already took all of the elements of the group. So, what is the group? Ang group natin is si C6. So, ano yung kanyang mga element? 0, 1, 2, 3, 4, 5, and 6. Yan po yung element ni Z6. Okay. Tingnan natin. The first one is 0 plus the H, which is your H03. Kaya nga, 0 plus 03 yan. Yan po ay H. So, this give us a 03. So, we have 0. Cancel out si 03. Next. Change natin yung 0 to 1. So, i-add natin yan, no? So, add 1 to 0, 1. Add 1 to 3, 4. Cancel 1 and 4. Wala pala tong 6, sorry. Kasi ang C6, pag naging 6 na siya, babalikan niya na si 0. Okay? We all know already discuss ko na yan nung last topic. I forgot anong topic yon. Okay. So, since meron pa tayong 2, 5, so continue natin sa 2. So, 0, 1, 2. Then, i-add natin sa 0, 3, which is your edge. 2 plus 0, 2. 2 plus 3, 5. So, cancel si 2 and 5. So, suffice or exhaust na natin. 0, 3, 1, 4, and 2, 5 already exhausted all of the elements of C6. Hence, these are all the cosets. Yun po yung cosets. Kasi since na-exhaust niya na, yan na po yung lahat ng cosets niya. Okay. For example, meron kayong, tinanong lang kayo, hindi kayo pinakuha ng ilang partitions meron sa ilang partition of cosets meron si subgroup H equal to 0, 3. How about tinanong kayo, how many cosets? So, ang gagamitin po natin si index. Yan. Yan po, no? So, we divide the number of elements in C6. Ilang elements meron si C6? Is 6. Ito yung kukunin natin, no? Yan po yung elements ni C6. I-divide natin ilang elements meron si H. Yan po yung ibig sabihin ng order. How many elements? So, si C6 may elements na 6. Si H may elements na 2. So, 6 divided by 2, we gives out 3. So, there are 3 cosets. Tingnan nyo. 1, 2, 3. So, there are 3 cosets. Yun po. Yun po yung ibig sabihin. Each containing 2 elements. Ma'am, bakit each containing 2 elements? Paano niya nalaman? Take note nyo sa theorem, ha? So, going back sa theorem. Sana yan? Dito ata yun. O yan. Every coset, left or right of a subgroup H, has the same number of elements as H. O, diba? Sinabi. Ano yun? Since meron tatlong cosets, so yung elements ni H is 2 elements lang. So therefore, yung mga cosets niya ay meron ding 2 elements. Kaya sinabi ko na dito, each containing 2 elements. Kasi yung cosets niya, kung ilang elements meron si H, yung mga cosets niya, ganun din yung kanyang elements. So since 2 yung elements ni H, so each of the cosets have or contain 2 elements also. So yun po yung ibig sabihin doon. So take note, no? Pag sinabi lang, how many cosets will there be in this blah blah blah. So alam na natin kung paano kunin. Use the index of a subgroup. So get the number of elements in the group, divides that to the number of elements of the subgroups, and we already get kung ilang cosets meron for this specific subgroup. Okay? So, yun. So, ganun lang pa yung pagkuha ng ating mga cosets. Okay? So, yun lang, no? Kunin lang natin. You add from 0, 1, 2, hanggang sa ma-exhaust niya na ang lahat ng groups, na elements ng group. Yon. So, we're done with the cosets. So, si cosets, may sumasama sa kanya si normal subgroups. Paano natin malaman na normal yan? Ayan. So, let H be a subgroup of G. Yan. H is called a normal subgroup if it is close with respect to conjugates. Dapat daw close siya with respect to conjugates. Anong ibig sabihin ng conjugates? That is, for any A element of H, si H po yung subgroup A, and X element of G. So, si G po yung group. Therefore, mag-i-exist po ito. Ito yung conjugates. Yan. Mag-exist po ng X, A, X inverse, which is must be element of the subgroup. Wherein X is in the group and A is in the subgroup. So, paano yan? Titingnan natin. Pwede din daw, tingnan natin no, sa example. Ayan. Ayun. Pwede din daw, pag ang left coset is equivalent to right coset. I forgot to write here. Left cosets is equivalent to the right cosets. Therefore, our subgroup is a normal subgroup. Yun. Yung left cosets niya is equivalent to right coset. Yung subgroup na yan is a normal subgroup. Pakilagay na lang to. Ilalagay ko na rin sa lecture na ipa-upload ko mamaya. So, kasi nalimutan ko ilagay. Okay. So, we have here an example. Isang example lang pala. Ayan. Don't worry, no? Since I have one example only, so I will try to give you later in the afternoon or tomorrow ng another example of normal subgroup. Isa lang pala yung subgroup ko. Kasi I will try to look for an example explaining this one. Explaining this one. Oh. Wait lang. Bakit hindi na siya magsulat? Ayan. Explaining this one. Para maipakita ko sa inyo na normal subgroups siya. Kasi for the RC example, I only give you na magkapareha si left and right cosets. So yan po yung isang pong criteria din para malaman natin na normal subgroup po siya. Okay. So we have here, no, for example, let H be an EA, a subgroup of a clean group, 4 group. Ito po yung group niya, and this is the subgroup. Yan. Ito po yung kanyang EA. So, if the letters adding to the identity, yan, same pa rin sa letters dito sa taas. Then this one, so multiplying 2e, so same pa rin yung letters niya. Pero pag parehas na yung letters, so example, we're talking about four group, clean four group. So AA equivalent to E, yung BB is equivalent to E, and yung CC is equivalent to E. While yung AB, kung ano yung wala dito, yun ang ilalagay natin. Kasi hanggang C siya, no? So AB is equals to C, ano pa ba? Sample, AC is equals to B. So, yung ano yung wala, anong letter yung wala, yun po yung magiging answers ng product. Okay? So, yun po yung clean for group. Ito na din yung example ng Cayley diagram or graph. Yung may binigay ako sa inyo doon. I don't know if it's in problem set or in final exam. Yung gagawa kayo ng table, ipipill up nyo lang. Okay. So, we will now determine the left cosets of H and the right cosets of H. Yan. So, if we can found that the left cosets of H and the right cosets of H are the same, therefore, the H is a normal subgroup of V. Ano yung V? Yan po yung clean four groups. Yan. So, kailangan natin ipakita na parehas yung left and the right cosets para masabi natin na normal subgroup siya. Kasi yan po yung criteria na normal subgroup din po siya. Okay. So, what are the left cosets? So, we have the EH, AH, BH, and CH. Saan po yung kinuha yung E, A, B, C? These are the elements under the group, which is the clean for group. So, pag meron dito left, meron nandito din po si right. Okay. So, i-multiply natin, no? Ito, ano yan? This is the elements of H, okay? So, same with this one dito, no? Change lang yung order. And then, you multiply. E times E, E times A. Yan. A times E, A times A. Yan pa yung mga answers dyan. Same with here. E times E, A times E. E times E, A times A. Yan. Okay? After that, ano yung answer ng EE? EE is E. EA is A. AE is A. AA is E. Yan, no? BE is B. BA is C. CE is C. CA is B. Product po yan, ha? EE is E. AE is A. EA is A. AA is E. EB is B. AB is C. EC is C, and AC is B. And we found out EH and HE are the same. AH and AE are the same. BH and HB are the same. CH and CB are the same. Dapat itong talaga magkapareha sila. It is their respective element. Kaya nga sinabi na lang dito, G, assuming G. G can be E, A, B, C, no? Therefore, GH is an element of HEB for all G element of H. Therefore, H is a normal subgroup of B. Dapat kasi si EH, the same with HE. Si AH, the same with HA. And dapat lahat ng element nito ay magkaparehas lahat. Hindi lang pwede si EH pati si AH ay magkaparehas. Yung BH and CH ay hindi. So therefore, hindi po siya normal subgroup. Dapat all of the elements must be the same, equivalent to the left cosets and the right cosets for it to be a normal subgroup of B. Okay? So that's it. So, any questions po tayo?
None, ma'am.
Okay, thank you for answering. So since no questions, so 8:33. So, ganon. Expect nyo na lang. So, I already uploaded uh, the problem set and the final exam. Yun po yung gagawin nyo for the rest of the semester. Kasi yung hanggang June 9, 10, 11 ang tayo. June 9, 10 is the final exam. So, yun po schedule ninyo, ipapass nyo na. You have 2 weeks to pass all of the requirements. At the same time, yung requirement natin, ay yung activity natin for the Module 3, Unit 3, which is the elaborate and the evaluate activity, give me until Monday to upload it. While waiting for the Monday, you can do your problem set and also your final exam. And some of the activities na wala pa nyong nagawa. Okay? Any more questions? Yes, Christian?
Wala po, ma'am.
Okay. Thank you for answering.
Kalimutan ko lang na off.
Okay. So, since this is our last meetup, so I just want, basta kompleto lang tayo, no? Pag hindi naman kompleto, basta hindi lang naman yung kalahati talaga yung hindi kompleto or mostly mas marami yung hindi kompleto kasa sa kompleto natin. Basta meron lang kayo 1, 2, 3 na hindi kompleto, okay na po yan sa akin. And I just want to congratulate to all of us for I would like to congratulate all of you for being with me for the last 5 months. So natapos na natin yung second semesters. And congratulations, you all passed our subject. So basta sa gusto ko lang is may ginawa kayong activity na makikita ko later on by next week. Makikita ko na yung lahat. Kasi nung last week, ginawa ko lang yung ating module and also yung mga quizzes and the midterm. I don't know if na-record ko na ba yung midterm. Parang quizzes pa lang ata. Okay, so that's it, no? So wait for may quizzes pa pala to, no? So i-upload ko lang next week yung quizzes. Unahin ko muna yung activities nyo for this module. And the quizzes, i-announce ko lang. Okay? So ibibigay ko lang din yung link sa ating Google Classroom or in our group chat. Okay, so if no more questions, can you open your camera for my documentation? Okay. 1, 2, 3, smile. Stop ko muna representing. Wait lang. Para mas klaro siya lahat. Wait lang Okay, 1, 2, 3, smile. Okay guys, thank you for your time Stay safe and God bless. So ito na yung last Google Meetup.
Goodbye,
Hindi
ma'am.
na tayo mag-meet next week. So ang gagawin nyo, go to your classroom, go to our group page. If may question, just PM sa group chat natin. Yun lang po. Updating lang po tayo. And I'd like to say, thank you guys for the 5 months na magkasama sa ating subject. And advance congratulations. You all passed to this subject, Math19 Abstract Algebra. Thank you. Stay safe po and God bless. Bye-bye.
God bless, ma'am.
Thank you
Bye.
po, ma'am.
Okay,
Bless
bye-bye.
po.
Bye, ma'am. Thank you po.
Bye. Thank you.